This video will go over the solutions for the prerequisite check for functions and relations. The first skill is to read values from a graph and table, and we'll use the given graph to answer the questions. So we have this graph of a polynomial function, which we'll learn about graphing those specifically later on, but we want to find out what value of y corresponds to x equals 0. So here we're looking for points on the graph whose ordered pairs of the form 0 some number. And if you remember graphing, the point 0 some number are points located on the y-axis. And so we have this point where x is 0 and y is 2. It's located on the graph, so the value of y that corresponds to x equals 0 is 2. What value of y corresponds to x equals -5? Another way we can find this information is to go to the x value of -5 and determine where the graph touches kind of that vertical line through -5, and that's at the point -5, 0. So the y value is 0. What value of y corresponds to x equals 2? So we go to x equals 2 on the x-axis, and we have to go down till we reach the graph. And so that's a negative value, maybe -1.3, -1.4. We're just approximating there. So approximately -1.4. Anywhere close is fine. For what values of x is y equal 0? So there we're looking for what values of x have a corresponding y value of 0. So that means we're looking at the order pair some number 0. And if you remember, those corresponds to the x-intercepts. So the y equals 0 is occurring at 1, 0, 4, 0, and -5, 0. So the x values are -5, 1, and 4. For what values of x is y equal to 4? So for this one, I'm going to think about this. We go to the y value 4, and we have to think about where, if we span across in horizontal directions, where do we touch the graph? That actually occurs in 3 different points: at -4, at -1, and at 5. So the y value, the x values then are -4, -1, and 5. Now we want to write a set of ordered pairs that corresponds to the points in the table. And we're given this table of x values and y values. To find the ordered pairs, we will just simply write a list of the corresponding x and y. So we have a -10 paired with a -15, so that's the ordered pair -10, -15. Then -5 is paired with -10, so -5, -10. -1 is paired with 0. 0 corresponds to 5. 1 corresponds to -10. 5 corresponds to 0. And lastly, 10 corresponds to 2. So that's just really getting you to understand that from a table of points we can actually list a set of ordered pairs, which is a relation, which you'll learn soon. Write the set of x values. So the x values are simply the -10, and we'll write them in a set: -10, -5, -1, 0, 1, 5, and 10. The set of y values are negative 15, negative 10, 0, 5, and then notice we have negative 10, which we've already included, 0 we have already included, and then 2. So then what y value corresponds to x equals 10? We can find that information from our table or set of ordered pairs, but x is 10, then the y value is 2. What value of y corresponds to x equals 0? So we find x in our x column, or 0 in our x column. We see that that corresponds to 5. For what values of x is y equal to negative 10? So now we find negative 10 in the y column and figure out what values of x correspond to that. So that's negative 5 and 1. For what values of x is y equal to 0? So here again we find 0 in the y column and figure out what corresponds to that from the x, and that would be a negative 1 and 5. Now we want to be able to evaluate algebraic expressions. We're going to find the value of each of these expressions when x is negative 5, 0, 1/2, or 4. So at negative 5, I'm going to make a chart here. Think about this expression as being y. When x is negative 5, we would have the square root of negative 1. And for the purposes of graphing and things that we're going to do, that's not a real number. It is the imaginary unit I, but we'll just say not a real number. If we substitute 0 for x, the square root of 4 is 2. If we substitute 1/2, we would have to add 1/2 to 4 by getting a common denominator. 4 is really 8 halves, so 8 halves plus 1/2 would be 9 halves. And we'll write that right now as the square root of 9 is 3 over the square root of 2. And then if we substitute x with 4, we would get the square root of 8. And the square root of 8, because it's 4 times 2, is really 2 on the square root of 2. Now if our expression is 1 over x, and we substitute negative 5, 1 divided by negative 5 is just negative 1/5. If we replace x with 0, 1 divided by 0, if you recall, is undefined. If x is 1/2, 1 divided by 1/2 is really 1 times the reciprocal, which is 2. So 1 divided by 1/2 is 2. And then if we have x to be 4, 1 divided by 4 is simply 1/4. Then our last expression is the opposite of the absolute value of x, minus 2. If we replace x with negative 5, we would have the opposite of the absolute value of negative 5, minus 2. But the absolute value of negative 5 is 5, and the opposite of 5 is negative 5. So we really have negative 5 minus 2, or negative 7. If we replace x with 0, the opposite of 0 minus 2 is just going to be negative 2, right? Because the absolute value of 0 is just 0. We put in 1/2. We have to do the opposite of the absolute value of 1/2, minus 2. Well, the absolute value of 1/2 is positive 1/2, but then we have to take the opposite of that, which is negative 1/2. So negative 1/2 minus 2 is going to be a negative 9/2. And then lastly, if we have 4 for x, the opposite of the absolute value of 4 minus 2. Well, the absolute value of 4 is 4. The opposite of that is negative 4. Negative 4 minus 2 is negative 6. Skill 3 is to determine values for which a rational expression is undefined. We've talked about this several times before, but a rational expression is undefined when the denominator is 0. And so we'll set the denominator equal to 0. In the expression x minus 4 divided by x plus 7, we set x plus 7 equal to 0. Therefore, it is undefined when x is negative 7. In the expression a divided by a squared minus 81, we set a squared minus 81 equal to 0. And get then that a squared is equal to 81. So by the square root property, a will be either positive or negative square root of 81, which is positive or negative 9. Number 15 is 3 divided by t squared plus 16. So we set t squared plus 16 equal to 0 and solve. If we applied the square root property, we would say that t squared equals negative 16. And so t would be plus or minus the square root of a negative number. Well, that's plus or minus 4i. And so since the only solutions of this equation are imaginary, that means there are no real number restrictions. So this one has no restrictions. In other words, it's defined for all real numbers. Okay, and then 7x divided by x squared plus 3x, we set x squared plus 3x equal to 0. This is a binomial that has a common factor of x. So if we factor out the x, we get x times x plus 3 equals 0. And now we set each of those factors to 0 to get either x is 0 or x plus 3 is equal to 0. So the two solutions are 0 or negative 3. So this particular expression is undefined at x equals 0 and x equals negative 3. Then we wanted to find the values for which a radical expression is a real number, and here we're really referring to just square root expressions. So a square root is defined or is a real number when we have a positive number inside the radical, right? Because the square root of a negative number is that imaginary number that we've talked about before. So for a square root expression to be defined, the radicand has to be greater than or equal to 0. So for the square root of x plus 3 to be a real number, we want to set x plus 3 to be greater than or equal to 0. So that's equivalent to that is equivalent to x is greater than or equal to negative 3. And in an interval, right, if that is viewed on a number line, we get everything to the right of negative 3 and including negative 3. So as an interval, that is from negative 3 to infinity. The square root of x minus 7, we set x minus 7 to be greater than or equal to 0. So that gives us x is greater than or equal to 7. And as an interval, that would be from 7 to infinity. For the square root of 2x plus 3, we set 2x plus 3 greater than or equal to 0. So 2x is greater than or equal to negative 3. That leaves x is greater than or equal to negative 3 halves. So as an interval, that would be from negative 3 halves to infinity. And then the last expression is the square root of 3 minus x. So for this to be a real number, we have to set 3 minus x greater than or equal to 0. We subtract 3 to get negative x is greater than or equal to negative 3. And then we divide by negative 1. Recall that dividing by negative 1 is the same as x is less than or equal to 3. Right? We have to reverse the symbol if we divide by negative. So x is less than or equal to 3 is everything to the left of 3. So our interval for this problem is negative infinity to 3 with a bracket.